This is grade 12 economics revision lesson provided by the Ministry of Education. In the previous lesson, we saw production function with one variable input labor. Today, we are going to see the production function with two variable inputs. An Isoquant schedule shows the various combinations of two variable inputs that gives a producer equal level of outputs. In the following model, the farmer produces the output weight by employing two variable inputs called capital and labor. So, the outputs that the farmer gets from the combination of one tractor and 8 labor is always equal to the output that the farmer gets from the combination of 2 tractor and 5 labor. Because as we increase employment of the variable input tractor, we are reducing the employment of the variable input labor. For example, if the farmer gets 60 quintal of weight output from 1 tractor and 8 labor, then the output that he gets from 2 tractor and 5 labor is also 60 quintal. Again, when we come across from combination B to C, the output that the farmer gets from 2 tractor and 5 labor is equal to the output that he gets from the combination of 3 tractor and 3 labor. As the farmer increases employment of the variable input tractor, he is reducing employment of the variable input labor. So, the farmer gets 60 quintal from 2 tractor and 5 labor, and again the farmer gets 60 quintal from employment of 3 tractor and 3 labor. Then finally, when we come across from combination C to D, then the output that the farmer gets from the combination of 3 tractor and 3 labor is equal to that of 4 tractor and 2 labor. As we increase employment of the variable input tractor, we are reducing employment of the variable input labor. So, the farmer gets 60 quintal of weight from the combination of 3 tractor and 3 labor. At the same time, the farmer gets 60 quintal of weight from the combination of 4 tractor and 2 labor. So, this Isoquant schedule shows the various combinations of two variable inputs that gives the producer equal level of output. The Isoquant curve shows the graphical representation of the Isoquant schedule and just represent the amount of the variable input labor that is given up in the y-axis and represent the amount of the variable inputs capital that is gained in the x-axis. So, from this Isoquant curve, the output that the farmer gets at combination A, the farmer gets 60 quintal of weight from combination of 8 labor and 1 capital or tractor. Again, when we come to combination B, the farmer gets this 60 quintal of weight with the combination of 5 labor and 2 tractor. Then, as we come across to combination C, the farmer gets the 60 quintal of weight from a combination of 5 labor and 3 tractor. And at combination D, the farmer gets this 60 quintal of weight from 4 capital and 2 labor. So this Isoquant curve, simple Isoquant, shows the various combinations of the two variable inputs, labor and capital, that gives the producer equal level of output. On the Isoquant, any point on the Isoquant represents equal level of output. If the output is 60 quintal at this point, it is 60 at this point, it is 60 at this point, and again it is 60 at this point. Now from this, let's see some of the properties of the Isoquants or characteristics of Isoquants. First of all, Isoquants are negatively sloped. Isoquants are downward sloping or negatively sloped curves because there is an inverse relationship between the two variables capital and labor. As we increase implement of the variable input capital, we are reducing implement of the variable input labor. As we reduce implement of the variable input capital, we are increasing the variable input labor. So due to this inverse relationship between the two variables that are entered in the x and y axes, then the slope of such a curve is negative. Another property on isoquant, isoquants are convex to the origin. This is the origin. When we see from the origin, isoquants are convex to the origin. Isoquants are convex to the origin due to the principle of diminishing marginal returns. The principle of diminishing marginal returns states that the rate by which one variable input is substituted for another on the same isoquant tends to diminish or decline. So due to the principle of diminishing marginal rate of technical substitution, isoquants are convex to the origin. Another property of isoquants never cross each other. Cross-secting isoquants indicate that there is inconsistent employment of the variable inputs, labor and capital. Another properties of isoquants from the isoquant map. The isoquant map is a group of isoquants. From the isoquant map, higher isoquants represent higher level of output. That means the output that we get from isoquant 3 is higher than that of the output that we get from isoquant 2. The output that we get from isoquant 2 is greater than that of the output that we get from isoquant 1. So higher isoquants represent a higher level of output and lower isoquants represent lower level of output. Okay, this is about the properties of isoquants. Isoquants are negatively sloped or downward sloping curves. Isoquants are convex to the origin. Isoquants never cross each other, and higher isoquants represent higher level of output and vice versa. Vice versa means the opposite holds true. That means lower isoquants represent lower outputs. And finally, the marginal rate of technical substitution is the slope of an isoquant. That means marginal rate of technical substitution, MRTS, is the rate by which one variable input is substituted for another on the same isoquant. The MRTS of capital for labor is calculated by changing the amount of the variable input that is given up, which is labor, and the changing the variable input capital that is gained, which is tractor or capital. And when we plot the isoquant, we represented the variable input labor in the y-axis. So changing labor means changing y divided by, we represented the capital in the x-axis, which is changing k. Changing k means changing x. So this is the vertical difference divided by horizontal difference, and we can get, by dividing the vertical difference for the horizontal difference, we can get the slope of a curve. So in other words, marginal rate of technical substitution is the slope of isoquants. Now let's see the marginal rate of technical substitution. In the model that we built to show you the isoquants, the marginal rate of technical substitution is the rate by which one variable input is substituted for another on the same isoquant. Now let's see the marginal rate of technical substitution using the following model. If the output that we get from combination of 1 tractor and 8 labor is equal to that of 2 tractor and 5 labor, then the marginal rate of technical substitution is 3. The MRTS of capital for labor is calculated by changing the variable input labor for the changing the variable input capital, which is gained. and this is labor final minus labor initial divided by capital final minus capital initial. Now let's take this one as capital initial and this 2 as capital final. Let's take this 8 as labor initial and this 5 as labor final. And then when we substitute this information on this formula, the value of labor final is 5 minus labor initial is 8 divided by the value of capital final is 2 minus capital initial is 1, which is minus 3 divided by 1, and then we get minus 3. When we put it out of absolute value, we get 3. This indicates that as we increase implement of the variable input tractor from 1 to 2, if implement of the variable input labor decreases from 8 to 5, then we are substituting 1 tractor for 3 labors. Again, as we come across from combination B to C, if implement of the variable input tractor increase from 2 to 3, then the implement of the variable input labor decreases from 5 to 3. Let's take this 2 as capital initial and this 3 as capital final. Let's take this 5 as labor initial and this 3 as labor final. And then when we substitute this information on the formula, we get the value of labor final is 3 minus labor initial is 5 divided by capital final is 3 minus capital initial is 2, and then 3 minus 5 is minus 2 divided by 1, and this is minus 2, and when we put it out of absolute value, we left with 2. This indicates that as we increase implement of the variable input tractor from 2 to 3, if implement of the variable input labor declined from 5 to 3, then the rate by which one variable input is substituted for another is 3. That means we are substituting 1 tractor for 3 labor. Similarly, when we come across from combination C to combination D, then as we increase implement of the variable input tractor from 3 to 4, that means tractor was initially 3 and tractor finally reached to 4. As a result, the amount of the variable input labor decreases from 3 to 2. That means labor was initially 3 and finally labor declined to 2. And when we put this information in this formula, the value of labor final is 2 minus labor initial is 3, and the value of tractor final is 4 minus tractor initial is 3, and then this is minus 1 over 1, and we left with minus 1. When we put it out of absolute value, we left with 1. So this tells us as we increase implement of the variable input tractor from 3 to 4, if implement of the variable input labor declined from 3 to 2, and then the rate by which one variable input is substituted for another on the same isoquant is 1. That means we are substituting 1 tractor for 1 labor. There is a law called the principle of diminishing marginal rate of technical substitution. The principle of diminishing marginal rate of technical substitution tells us the rate by which one variable input is substituted for another on the same isoquant tends to diminish or decline. In short, the principle of diminishing marginal rate of technical substitution tells us as we move from one combination to another, the marginal rate of technical substitution will always decline. For example, as we come across from combination A to combination B, then we are substituting 1 tractor for 3 labor. When we come across from combination B to C, we are substituting 1 tractor for 2 labor. And finally, when we come across from combination C to D, we are substituting 1 tractor for 1 labor. So the rate by which one variable input is substituted for another on the same isoquant tends to decline. First, we substituted 1 tractor for 3 labor, then 1 tractor for 2 labor, and finally 1 tractor for 1 labor. This is all about the day's revision lesson. Stay safe, stay home. Thank you.